Climate change has been in the news for years. But what is it, and how will it affect us? To understand climate change, you first need to know about the greenhouse effect. The Earth gets heat from the sun. In the atmosphere, greenhouse gases like carbon dioxide trap this heat and keep it from escaping back to outer space. Trapping some heat in the atmosphere is a good thing because it keeps the planet warm enough for us to live. But there's a problem. People all over the world are adding extra carbon dioxide to the atmosphere. That's because today we burn fossil fuels like coal, oil, and gas to do many of our everyday activities, like driving our cars, using our computers, and heating our homes. All of this extra carbon dioxide is trapping more heat in the atmosphere, making the Earth warmer and causing other climate changes too. The signs of climate change are all around us. Temperatures are getting warmer, giant ice sheets are melting, and the oceans are rising. In many places, flowers are blooming earlier, snow is melting sooner, and birds aren't flying as far south for the winter. So why does this matter? Well, if the planet keeps getting warmer, we can expect more powerful storms and more flooding, droughts, and heat waves. And these changes could cause additional problems, like the spread of certain diseases, more wildfires, and food and water shortages. Climate change could put entire ecosystems, like coral reefs, in danger, and many plants and animals could become extinct.
The only constant is change. That's true about life, and it's true about the climate. The climate has been constantly changing since the Earth was formed 4.6 billion years ago. For example, in just the past 2,000 years, we have seen the Roman warm period, when it was warmer than today. Then came the cooler Dark Ages, followed by the medieval warm period, when it was at least as warm as today. Then we had the Little Ice Age that drove the Vikings out of Greenland, and most recently, a gradual 300-year warming to the present day. That's a lot of changes, and of course, not one of them was caused by humans. During the past 400,000 years, there have been 4 major periods of glaciation, meaning that vast sheets of ice covered a good part of the globe, interrupted by brief interglacial periods. We are in one of those periods right now. This is all part of the Pleistocene Ice Age, which began in earnest 2.5 million years ago. It's still going on, which means that we are still living in an ice age. That's the reason there's so much ice at the poles. 30 million years ago, the Earth had no ice on it at all. So then what about carbon dioxide, the great villain of the global warming alarmists? Where does that fit into this picture? Not as neatly as you might think. Temperatures and carbon dioxide levels do not show a strong correlation. In fact, over very long time spans, periods of hundreds of millions of years, they are often completely out of sync with one another. Over and over again, within virtually any time frame, we find the climate changing, for reasons we do not fully understand. But we do know there are many more factors in play than simply the concentration of CO2 in the atmosphere. Factors such as the shape and size of the Earth's elliptical orbit around the Sun, activity from the Sun, and the amount of wobble or tilt in the Earth's axis, among many others. Even the relatively short 300-year period from the peak of the Little Ice Age to the present has not been steady. The latest trend has been a warming one, but it began nearly a century before there were significant carbon dioxide emissions from burning fossil fuels. And there has been no significant warming trend in the 21st century. Contrary to media headlines, the trend over the past couple of decades has been essentially flat. Meanwhile, human-caused CO2 emissions are higher than ever. About 25% of all the CO2 emissions from human sources have occurred during this period of no net warming.
How can we distinguish between variations due to natural causes and those variations of the climate that are induced by human activity? And the key thing that convinced me, at any rate, was a graph like this one that we marked out on the floor that had been prepared from climate scientists like Professor Peter Cox. Now, explain to us the significance of this graph.
Okay, what we're going to do is to take a walk through time. And the first thing to note as we walk through is that the climate is naturally variable. It's a spiky beast. Occasionally there's a downward trend that's associated with a volcano going off that cools the system down because of the dust it throws up. But generally it just oscillates around. And then we get to a period around about 1910 where you can start to see an upward trend, a warming of the climate, a global warming if you like. And the issue is, what caused that? Was that humans or was that natural? So what we do to try and work that one out is to take a climate model and to put in the various factors. And what we can see with this green curve here is a climate model that includes just these natural factors. So this is when volcanoes go off and the output from the sun. And you can see that the green curve can reproduce reasonably well this mid-century warming. So up to this point, you could reasonably argue climate variation can be explained by natural factors. But as we move on, we can see that's no longer true as you get to the latter part of the 20th century. From about 1970 onwards here, you can see the red curve, the observed temperatures, and the green curve really beginning to diverge. And the question again is, what caused this recent warming? So we run the model again and we include human factors. Particularly we include the greenhouse effect, mostly from carbon dioxide that comes from fossil fuel burning. And then we get this yellow curve, and we can see, as well as reproducing the mid-century warming, we get this recent rather rapid warming reproduced. And that tells us two things. One is that the model looks realistic, it looks like the real world. And the second thing, the model tells us that this recent warming is due to human beings.
So there you have it. There seems little doubt that this recent rise, this steep rise in temperature, is due to human activity. If you look at the green line of natural variability, it's clear that without the action of human beings, there would have been far less temperature change since the 1970s.
It's ridiculous. Now, this is what they have come up with, however, and this is for the last 19 years, roughly speaking, the temperature has not gone up. It's been constant for 19 years, almost as long as the life of the students here. They're probably at 23, 24 years old. So it hasn't gone up. And there was a big peak in 98, that's very recognizable. So what did the people who measured temperature do with that? Well, here is the latest temperature they have measured now, and they see the curve here, and if you look at the edge here, it goes up. I made a bit better one here. The temperature here goes up. How can that be when I just showed you the other curve, the temperature has been constant? Well, the reason for that is that they include now the ocean. But for 100 years, the ocean has not been included. Why do you think they include the ocean? Because it's more accurate, or because they can fiddle with the data? That's what NASA does. So Obama said last year that 2014 was the hottest year ever. But it's not true. It's not the hottest year. So if you don't believe I'm cheating you, here's some satellite data, and this is the peak in 98, and you see basically the satellite data shows the same thing.
So last week, Breitbart.com published an article claiming that global warming was nothing but a scare and global temperatures were actually falling. Problem is, they used a completely unrelated video about La Nina with my face in it to attempt to back their point. Now, what's worse is that the U.S. Committee on Space, Science, and Technology actually since the middle fell this year, the biggest and steepest fall on record. Now, that was based on one satellite estimate of global land temperatures, not a consensus. And second of all, land temperatures aren't an appropriate measure. The Earth is 70% water, and water is where we store most of our heat energy. So when you look at sea surface temperatures and you combine that with land temperatures, you actually get a record high for November of 2016. Their second claim, it can be argued that without El Nino, 2014 to 2016 would not have been record warm years. Now, you're taking a look at the Arctic sea ice melting here in this video from NASA. When you actually normalize the data, aka take out the El Nino spike in temperatures, 2015 and 2016 still come in as the warmest years on record. So that brings me to claim number 3. Many think that 2017 will be cooler than previous years. Now, it is typical, yes, for temperatures to drop in a post-El Nino environment, but certainly not to record lows. If that claim was correct, we would have had global record lows all over the last century, and we haven't seen that since 1911. The last time we fell below the 20th century average was in 1976, and guess what? That was directly following the 1974-1975 strong El Nino. So next time you're thinking about publishing a cherry-picked article, try consulting a scientist first. And to all my fellow scientists out there, let's make the facts louder than the opinions.
Miles Allen is a professor of geosystem science at the Department of Geography here in the Department of Physics here at Oxford University. He's also served on several IPCC reports. How do you respond to Professor Lindzen when he says, where does this 90% figure come from?
The evidence is entirely consistent with most of the warming, or indeed all the warming, being driven by the the build-up of greenhouse gases in the atmosphere, which puts the future into perspective when we think about the fact that we had 250 years ago 4 trillion tons of fossil carbon underground. We've burnt about 500 billion tons and caused somewhere between 3/4 of a degree and a degree of warming. That's taken us 250 years. We'll burn the next 500 billion tons in 35 years. We'll burn the next 500 billion tons in maybe 30 years. And we'll burn the next, we're not going to stop doing this because fossil fuels are such a fantastically useful resource. So that's where I see a mismatch between saying most of the warming to date is due to this build-up of greenhouse gases in the atmosphere and the statement that we won't see very substantial warming in the future if emissions continue, because that's exactly what's happening. This stuff is building up.
Where is the fundamental disagreement, do you believe, between you two?
Given the accelerating rate at which CO2 is accumulating in the atmosphere as emissions rise, we should expect an accelerating commitment to warming. So the statement that we've only seen a little bit of warming so far means it won't matter in the future, we won't see any warming in the future, flies in the face of our basic understanding of the way the carbon cycle and the climate system works.
Let me ask you a
Become so politicized on the topic, she can no longer handle what she calls the craziness of it all. Dr. Curry joins us now. Professor Curry, thanks for coming on tonight.
Tucker, it's a pleasure.
Well, thank you. It is for me. So you have written that part of the problem with climate science, not just at your school but at others, is that research money only goes to researchers pursuing certain lines of inquiry, and that they're all the same, and that prevents good science from happening. Am I mischaracterizing you?
Not really, but what you're seeing is there's this dominant theme of human-caused climate change, which is where all of the research and the focus is being directed, and there's far too little funding and effort going into understanding natural climate variability. That's my concern.
Right. So is that, for those of us who are non-experts, is that the key debate, not whether temperatures are changing, because of course they always have, but over what's causing that change? And is there a debate on that?
Exactly. No one debate. It's clearly warming, and it's been warming
Right.
overall for several hundred years. The key question is how much of the recent warming, say for the last 50 years, has been caused by humans.
Right.
And my interpretation of the evidence is that we really can't tell, and I don't see a clear signal that it's being caused by humans predominantly.
So for your position, and I think I'm just quoting you what you said, we really can't tell. You're not sticking out a hard position either way, but you're sort of open-minded, it sounds like. Do you believe you were penalized for that view?
Oh, I've been vilified by some of my colleagues who are activists and don't like anybody challenging, you know, their big story. So, I mean, I walk around with knives sticking out of my back. Yeah. And, you know, in the university environment, I just felt like I was beating my head against the wall and not being effective.
What's so curious, I mean, I live in a similar world, but it's a political world where people disagree and they have strong beliefs and ideologies and they attack each other over them. But that's sort of the opposite of what I understood science to be, where you were led by inquiry and evidence to conclusions, right?
Oh, exactly. Universities should be places of unfettered research, freedom of investigation, honest and open debate, diverse perspectives, etc. And in certain fields, you know, that are politically relevant, you're definitely not seeing that.
But I mean, this is one that has relevance for all of us, even though those of us who aren't in college or don't have kids in college. I mean, the research you're doing and that your colleagues, the ones you described as activists, are doing will inform public policy in a way that affects every person on the planet. So the stakes are really high, no?
The stakes are very high. Personally, I think I can have more of an impact outside of the university in the private sector, sort of free market, academic freedom.
Huh, academic. So let me ask you this. When you hear people who ask the question that you just asked, to what extent is climate change being driven by natural factors that have always existed, and to what extent by human activity? People who ask that question are derided as climate deniers. What's your response to that?
Well, my response is we really don't know. It's certainly humans are contributing something. We don't know how much. From the evidence that I've seen, I don't think it's the dominant cause. You know,
wait, but Dr. Curry, you're not listening to TV, because 98% of scientists globally believe one thing. So you must be in the 2%, right?
Ironically, the way the question is framed about the consensus that yes, it's warming, yes, humans contribute to it, I mean, everybody agrees with that, and I'm in the 98%. It's yes. When you get down to the details that there is genuine disagreement that is really glossed over in the media.
Interesting. We need to do a multi-part series on the show on this question. Just what do we know and what don't we know? As honestly as we can. And I hope you'll come back for that. Dr. Curry, thanks for joining us.